Hey, welcome in everybody. I'm Brian Reeb, and today I have the privilege of getting to talk to two genuinely smart people here about the world of hardening, security, and the day-to-day keeping of Linux fleets in line. Brian Dawson, Larry Adams, thanks for being here.
Awesome. Excited.
Glad to be here.
Nice. So a quick bit of housekeeping before we start. If a question comes up, we encourage you to put your question in the comments. We will try to address them at the end. If you're catching this on demand, please leave us a comment in the video. We keep an eye on those in YouTube, and we like to reply, and we generally love to hear from people, whether you're doing it in live or on demand. So to start off today, I just want to set a little bit of a level playing field here. When you set a hardening goal, the instinct is to focus on getting there. It's that first pass that matters. It is important, but it's only the first step. The ongoing problem, the one that tends to get overlooked, is keeping a fleet hardened and staying ahead of that drift that creeps in over time. Brian, Larry, before we get in on how to fix it, help me understand what the problem really is. So Brian, specifically, you are knee deep on security and compliance side of things all the time.
Yes.
What actually happens to a hardened box the day after someone signs off on it? In particular, I just want you to make sure can you talk about some of those common struggles that people face when they're approaching it, what it looks like in the real world?
Yeah, and I'm going to get to the question about what happens after it's hardened, but first start with what's kind of important is what happens when you're told you need to harden a system, right?
Perfect.
And oftentimes this is, for better or worse, the people that are focused on this or the people that learn they have regulatory concerns and they have to become compliant for a business reason. Right? You have a government contract, you're a DoD, you're dealing with payment processing, you need PCI DSS, etc. And oftentimes that means, okay, we've been managing a Linux fleet. We now have this new compliance guide that we need to go through and understand anywhere from 100 and something controls, from 170 controls, all the way up to, if you layer them, as many as 879 controls, right? And all of these require that you tweak and tune various levers on your system, such that when you run a scan, you pass, okay? Now, at CIQ, and me as director of product, we figured one way to solve this problem is to just deliver compliant Linux images out of the box, right? So you lay them down, you boot it, and we have you at 95+% compliant out of the box. And that saves some time, right? Because then you just got to tweak and tune a few variables, right? But now we meet the reality of what modern hardening looks like. If you are at an enterprise, you are managing fleets of 100 to 1,000 servers. You have cattle and not pets. And the first thing you run into is actually, how do I harden all those systems, right? And we give you an image, great, but then deploying those images efficiently across a fleet is difficult. So enter the answer. We deliver hardening playbooks that will allow you to take your generic fleet of, say, Rocky community servers and run playbooks across your fleet and get them up to 95+% compliance, and even more if you tune the controls, right? So that's where you start. Great. We have very efficient playbooks. We've gone across our fleet. We scan them. Our fleet is compliant. But as somebody from the DoD stated to me, when does configuration drift start? Well, configuration drift starts as soon as you lay down that image, right? Now, one of the things that happens is at the end of the day, you're delivering servers to run workloads, right? And this is like, well, we developed something in a clean room. Now we deploy it in the wild, and we have application dev teams that are running into issues because the port's turned off, the cryptography standard is high. And they will either start asking you to change those systems. They will start changing those systems themselves. And before you know it, your beautifully hardened fleet is, 100 different configurations of hardening, gradually moving out of compliance with your baseline presenting regulatory risk for you. Now, for a sysadmin, both that hardening process manually as well as the whack-a-mole of managing configuration drift consumes critical time, right? Time that you might be chasing down CVEs and ensuring your security posture, time that you might be deploying modern infrastructure. So that's the problem we have to solve, right? You are either balancing, Reed, to close out, um, speed versus risk, right? And that means I can decide to go fast and not maintain compliance on all my systems. I'm getting exposed to risk. Or I can err towards mitigating risk, and it may crawl my infrastructure team. I mean, bring my infrastructure team to a crawl. So what we need to do is enable a reasonable balance of speed versus risk.
Got it. Got it. And so, Larry, just you get to see this from like a sleeves rolled up kind of standpoint, from the sysadmin kind of view standpoint. Anything you want to say to elaborate on what Brian just said, keeping the whole fleet hardened, that week to week grind, and what that looks like, what people like kind of experience from a pain point standpoint?
Well, from my experience, of course, hardening is important, right? As an operations person, as a person who's been in HPC for years, we see a lot of issues like this where we have, CVEs and whatnot causing risk to the environment. So from a commercial HPC's perspective, it's really important that you have a rigorous process, that you have people that are testing all the applications. In an HPC, in a commercial HPC setting, you could have 30, 40, 50 applications that all have to be vetted. You can have a container first environment, and you have to measure those compliance rules with what's in the container. I've found examples just recently where certain applications just don't run because the STIG or the CIS hardening basically locks down things that are foundational to running inside of containers. So it's really, really important to have a rigorous process. So you have specifically in commercial HPC, you have a CAD team that's vetting all their applications throughout the process of the hardening, right? I'm assuming that we're bringing hardening into an existing environment. And whether it is an existing a greenfield environment or a brownfield environment, you still have to do the same checks and balances, right? Because in the end, and especially in a commercial HPC, it's the product, not the process. But at the same time, you have to protect the IP of the company and prevent risk. And this is especially important in large HPCs because the surface area for running things like DDoSes internally or externally is really, really large in those spaces. So I'll leave it at that.
Yeah, that gives us some good
all about
context.
operations.
Great context of kind of what people are kind of running into. Before we get into the solution and the context on how that works, I just want to level set a lot of people who might be coming in here new to a little bit of the stuff that we do at UCIQ, on the players in how we're approaching the solution. So, Brian Dawson, can you give me just a quick level set on what exactly RLC Pro Hardened is, in plain terms?
Yeah. So RLC Pro Hardened is a workload optimized version of Rocky Linux that aligns with the CIQ mission statement of we're delivering the modern performant and secure IT stack for the AI generation, right? And with Pro Hardened specifically, we realized this problem statement that we covered earlier, and we built a system that delivers both compliance hardening, i.e., this pre-remediation to mitigate the thrash and risk with hardening your systems for compliance reasons, and then as shown on the screen here, proactive hardening, which in addition to supporting DISA STIG, CIS, NIS 800-171, and going forward, PCI DSS and HIPAA, as well as other standards. During that time, when you can't patch your system or harden them, as the slide showed, we deliver LKRG. We delivered hardened modules that are common attack vectors. We harden your credentials. And then we deliver and manage these as overall hardened configurations. And what Pro Harden enables you to do, again, is to quickly achieve compliance, quickly achieve protection when your system can't be hardened and patched, i.e. in those periods of drift, while enabling you to do that in a quick and performant way.
Nice, nice. And then similarly, Larry, can you just give me a high level context as to what Ascender Pro is? Because I think this is the other part of the solution that kind of plays into it. And Brian kind of alluded to the whole idea of playbooks, but I want to just make sure that we're level set, not just for people who might not know what Ansible is, but even if you don't know what Ansible is, what is Ascender Pro? What does it look like? And how does it work?
Well, Ascender Pro is really comes from the genesis of the whole Ansible project. Originally, Red Hat had come up with a product called Tower, and what Ascender Pro has done, is bring everything from the legacy, what we call AWX environment, into CIQ, and we're doing things like patch remediation. We're keeping up to speed so that there's no CVEs in the product. And then in addition, we provide compliance reporting with a tool we call Ledger. And Ledger gives us an idea of what's installed on every system, whether it's compliant, whether it's exposed to CVEs. We have another product we call Registry. And Registry is a way, if you're familiar with Ansible, of having a vetted Galaxy basically repo for your various collections. So you decide what collections need to be there, and then that way you able to vet the public domain before it makes it into your corporation. And then we have React, which is a log processing module that talks about what mitigation we need to take, and then finally a Galaxy proxy product that if you're not using Registry, we made that available to the open source for people to really kind of de-risk outages in Galaxy, which happen from time to time. So it's really about maintaining, the whole suite is about maintaining your fleet, doing patching and compliance checking, auditing. You can do things like deploy machines, virtual machines, and tear them down. It's a really robust tool for basically running all your patching and compliance operations. And it's enterprise grade and scales rather well.
And if I can call out, one of the things that is extremely valuable about it is that people are used to executing their Ansible playbooks and Ansible commands often from the command line. And to have a well-organized GUI in front of this that allows you to easily correlate your jobs, analyze runs, et cetera, like with Ledger Pro, we've gotten feedback that makes a huge difference in terms of managing your fleet at scale.
Absolutely, and control the credentials. You don't have to let your credentials get out of control. They are in one place, and that's in Ascender.
Yep. Yeah. So no, that's good context on kind of both pieces and sides of this stuff, and it's a good segue when you're kind of hinting at the interface and all that kind of stuff into let's get into how we solve this problem and what the problem that kind of looks and feels like and where that leads to. So there's two kind of aspects at it, and Brian, you kind of hinted at it, which is like, how do I tackle that first part of hardening a fleet to begin with? And then after that, I want to talk into like, how do you manage that drift afterwards as well? So Larry, let me push it to you. And can you go through what that solution looks like on how do I manage hardening my fleet? What is using Ascender Pro to kind of get that done for you?
Well, yeah. So really, the first part is to set yourself up the Ansible Pro fleet, connect the registry to our Depot Galaxy instance, and then you can pull down the hardening playbook. Once you've done that, you set up job templates in Ascender that are going to set up a baseline compliance check, a drift check, and a hardening check. And then you test it on systems. You test it on a few systems, and of course, you're going to vet that image, in the testing process. So you're going to pick some pre-prod systems or some development systems, and you're going to apply the hardening that you think is the right recipe for your organization. And then you set your CAD team about testing all their applications, verifying you get full functionality throughout that process. And as we see on the automation path here, we see the operators. Those could be APIs, or those could be MCPs or any other type of operator. They access a sender. A sender pulls what it needs relative to hardening from registry, and it'll deploy tasks to this thing we call the Ascender EE, which then will patch and remediate your hosts. And they're pulling their data again from the global Galaxy server, if you allow that, or from your curated Galaxy server that comes through CIQ's Galaxy. Once you've got the recipe, you just move that to production, and of course monitor it and monitor the drift. In the examples we will show here shortly, you can see there's hardening for the various forms of hardening and drift detection as well.
Yeah, and I'd like to throw out or emphasizing, and if you have any additional comment, Larry, share. One of the things that is, I think, valuable with that setup and the solution the team has designed is the ability that I can go out and harden, say, community RLC or Rocking Linux from CIQ Pro hardened servers. Great. I can re-harden them, remediate drift. But what is also interesting and running into a lot is I have Rocky deployed in my HPC environment. I have Rocky deployed across my nodes. I realize I have a compliance need, and that first pass of the playbooks that Larry will show you will enable you to effectively turn a community Rocky into a compliant hardened Rocky. And hopefully, Larry, you'll cover the playbooks were designed to not be opinionated and prescriptive, but to expose what we call VARs and roles to allow you to quickly just tailor what you want to cover via flags and setting of VARs.
So this isn't just, hey, here's the process of by which you're going to be doing it. Go out and build your own playbooks following this path. This is actually, here are the playbooks that are going to help you run these types of things. Does that sound about right?
That's correct.
Yeah. And on the other end of that, I'd say that's correct, but it's also not, here goes the one recipe for hardening, because every organization and every team, the infrastructure team support is different. So it's a mix of, we're not just giving you a set of tools, right? Or parts for a car. We're giving you the car, but you can adjust the interior, change the tires, change the rim, and customize it to fit your needs.
So it's a good starting point, right?
Yeah, there's literally hundreds upon hundreds of hardening steps that these playbooks go through. And the beautiful thing about it is you can exclude any number of those in your setup. So let's say, for example, you have two environments in your corporation that have two different compliance needs. If you're an HPC, you've got to have NFS. If you just run CIS, it's going to disable NFS. That's not good in an HPC. But you may have another container-based platform that needs to be fully hardened with minimal threat surface. And so you may run the full CIS on that. And the beautiful thing about Ascender is you can either separate that by organization, or you can set up a whole set of playbooks that vary for the task. So it's very fungible in that perspective.
So do you mind if I bring up the screen just so you guys can talk about that interface? Because I think this is kind of a very sharp departure from what a lot of people know and think of as far as managing all these things through an interface rather than just doing it all command line and you having to look through files and that kind of stuff.
Awesome. That's sure good.
And Larry, you're going to talk to this, right? Yeah.
Yeah. So in here we're just showing, and it's maybe a little hard to read on the screen, but we're showing basically 5 different hardening playbooks. So we have DISA STIG, we have stock conversion to RLC hardened, which includes all the things that Brian had mentioned. These other playbooks actually do the conversion to RLC, or if it's already RLC, it doesn't have to do that conversion. Then we have CIS STIG and plus STIG, which has been a request, and Brian can talk to that a little bit, from some of our customers who want a mixture of both CIS and STIG. We have a full-on just STIG, and then we have this new NIST SB 800-171. Followed up by that, we have 2 drift detection playbooks that will drift detect a set of systems against CIS and DISA STIG. And the beautiful thing about these is the playbooks are already there. The only thing you have to do is find the variable selection that you need to match your compliance requirements, right? And yeah, so that's how it works. It's fairly straightforward. You point it at a fleet and you press go, and off it goes. It does its work. It's really a beautiful thing to see.
Yeah, and if I'll add, I think 3 additional comments. So you called out the CIS and DISA STIG, and this is something that is rather unique because we've had a particular heavily regulated customer that said, I have a varied fleet. At any given time, I don't know if my authority to operate is going to be based on compliance with CIS or compliance with DISA STIG. So we were able to create a playbook, one of its kind, that will enable you to, in under 20 minutes, or roughly 20 minutes, it may vary based on certain factors, but as low as 13 minutes, run a playbook and not only harden a system for DISA STIG compliance, but harden a system for CIS compliance. And some people may note that the cryptographic requirements for the two are different. STIG requires a stronger cryptographic requirement. So the playbook is intelligent enough that it will have a default for erroring towards the stronger cryptographic compliant and managing overlap, right? Or allow you to tune and choose otherwise. So that speaks to the fact that the playbooks alone are more performant than anything out there I can measure, because part of where this process gets tedious is you harden or you remediate drift. It's a 40-minute run or more with standard OSCAP guides per system. And then you find out you've locked yourself out of the system and you have to start all over again. So the iteration time is really, really costly. The other thing is what it takes to debug it, which Larry will show you more when you're looking through these immense run reports. And I'm forgetting the name, Larry, right now. So that UI that Larry just showed you, it gives you a notice of success, failure, time of runs, etc.
Yeah, it's essentially the playbook run. This next picture here is, before we go to that though, I wanted to stop for a minute. So if someone says, oh gosh, it's 20 minutes per run, I've got 1,000 systems, that's going to take forever. Another beautiful thing about Ascender is it supports this concept of fan out, and anyone who's been in HPC for a while knows what that means. That is the level of parallelism. And even with a smaller system, you can have a fairly wide fan out because all the work's being done by the execution engine as well as on the nodes themselves. So the amount of fan out, how quickly you can get this done is pretty immense. You can have parallelism above 100 concurrent nodes at a time, so it goes rather quickly. It's not necessarily a drawn out process.
So,
and then,
yeah, I was going to say, so help me understand where people typically run it now. How do they run this stuff now? Is it a lot of manual stuff that happens right now on an individual basis? And even for larger fleets, you're maybe just running your own playbooks on probably command line Ansible or something like an AWX that's old and not updated, or I'm getting to understand the speed factor here and how that is really, really helping, and how that can really kind of speed things up. But I'm having a hard time thinking about how, as someone who's not into the hardening stuff that much, how does that
what
look
this
right
looks
now?
like, what this looks like without the
Yeah,
solution.
because I get to see all these nice screens and it makes complete sense to me from the beginning, and I'm like, well, then how was it done before? How are people tackling it right now?
And I'm going to quickly jump in, but I think Larry has the more meaty part of the answer, right? And one is, as I've talked about, what it looks like without this visibility and without sort of the pre-baked turnkey hardening, is just a lot of churn. And oftentimes I'm seeing that, it is automated. It's, managed through a GitHub repository in mature organizations. But it is also managing that, what I call it manually, right? They're automated runs, but now we got to manage a whole collection of playbooks across different fleets, versioning and changing of those playbooks, etc. But Larry, love to hear what you see out there.
Well, you're talking to the wrong guy because, I'm a salesperson, right? Technical sales. So I would first tell you that, well, regardless of what you're doing today, come and use Ascender Pro. But with that said, I mean, it's all over the place. There are other commercial tools that are available for this. And, I challenge you to look at the versatility you have with Ascender versus those commercial tools. And there are people that roll their own because a lot of, especially in universities potentially, they may not have the budgets. And so they use shell tools, they cobble things together. Maybe they have good control of their credentials, maybe not. It's going to be all over the place. And there's when you go into, into the supplier community and looking from my perspective, it's mainly commercial HPC. When you get into tier 1, tier 2 suppliers, they're lucky and they need tools like Ascender Pro to really get them over the last mile. And the tools that we provide through, through Greg Kurtzer's stewardship of the company, right? We're open source first. We do have some commercial offerings, and that's part of the game. But again, just encourage you to take a serious look at Ascender Pro. Come join us.
Awesome. So talk to me a little bit about what it looks like afterwards, after you've gotten through the hardening process. It's been 6 months. Brian, you were talking about this earlier, how drift starts to happen.
It might be 6 hours.
Yeah.
But yeah, right.
Yeah.
Right.
Yeah. 6 hours is something that you can maybe, if you're on top of it, kind of make these small moves. But if you're waiting maybe 6 days or 6 weeks
Or 6 months.
6 months out, it just gets worse and worse and worse. What does that look like, and kind of how can this solution help you manage that drift?
Let Larry take a lead on that one. I'll jump ahead and go. I'll say quite literally, we have customers where this happens for 6 years, right? Or, to that order of magnitude.
Sure.
But Larry, I know you just went through that flow, and maybe you can talk about how you solve for that configuration drift after 6 weeks, 6 months.
Well, first of all, measure twice, cut once, better long than short, which is what my father always told me. Plan, don't do things without change management. I'll agree to a process, have a feedback loop inside of your organization, because the security team isn't necessarily going to be the same as the operations team. So you need to have those connections. You need to follow good change management. You need to be a well-functioning organization, especially in the enterprise world. And then you start doing drift remediation from day one and drift validation from day one. And it is a continual process because people, sometimes have credentials. They're working around customer tickets, trying to make things work. You've got to, got to run the business. And so when things do creep up, and they will creep up, you need to make sure that you're running that drift check frequently, right? We had a situation where a container was brought down from a third party, and that container runs inside the operating system, and a CIS rule basically fails immediately as soon as that container is cached on the system. So you're going to run into these things, and then when you do, you have to take the appropriate action. It could be getting with the container vendor or whoever's maintaining the container to fix those problems. It's all about operations. It's all about configuration management, change management. And again, in a container ecosystem, it's a little more broad. You have a lot more players that you have to work with, and those players don't necessarily conform to the standards within a corporation. So it is a kind of it's a ongoing process. It never goes away. And here's the last thing I'll say on this is that the standards are going to change. As Linux changes, the standards are going to follow with it, right? And so, invest in that as a corporation.
And Larry, and probably what my response should have been practically, right? We talked about long spans. You may have long spans where you might allow a system configuration to drift, like say military. Sometimes they have a saying, mission trumps all, right? So you may have systems in the field where it'd be disruptive. But that said, what Ascender Pro and Rocky Linux from CIQ Pro Hardened enable is continuous compliance, right? So this drift remediation job or drift detection job, you start with that, runs in minutes and can be scheduled to be continuously scanning your system. Now, to Larry's point, depending on the nature of the node, the server, when you detect drift, you have two options. You can flag it and figure out how to diagnose it and remediate it. But for certain deployments, nodes, and systems, you actually can just automatically then trigger the remediation playbook, which is item potent, meaning it won't it can safely rerun multiple times, so it'll only remediate the things that have drifted. But this starts to look like, hey, I set it and forget it for those nodes. I scan, I scan, I scan. Something is detected, bam, I remediate it. We are achieving continuous compliance at that point.
Yeah, absolutely. That's not only, there today. It's it's prudent on a properly vetted rule set, right? That you should do these things, but you should always know what caused the drift. And there's a whole nother conversation, we don't have to have it here, about that process operationally, right?
Great, great. Anything else before we start to wrap up that we want to show or talk to that we've didn't mention? I just want to make sure that we're covering everything and that we've hit all those highlights on that stuff for you guys.
Well, I mean, the only other as a sales guy, right? The only thing I'd like to show is how React works, just at a high level, so people can see this and have that as a going away present, for them to take back and think more about. So if you could bring that slide up real quickly. Yeah. So this is basically event-driven automation. On the left-hand side, you see an event coming off a host. It's usually forwarded through syslog to React. React gets a chance to inspect that. It goes against its rule set, and if it finds that there's a problem and it has a known workaround, it can literally trigger a workflow inside of Ascender Pro that remediates that problem right away. It could be like cleaning up a temp drive, it could be reconfiguring DNS, or we actually have an option to query an MCP and have the MCP come back with a response. And if it's a known response, you already have a playbook to remediate that. You can then trigger that directly from React into Ascender Pro to do remediation. So, and this React is hyper scalable. You have a central React server, and you can put listeners on the edge or wherever within your organization to take these remediation steps. And so I would say it's an N-tiered architecture that is really well thought out. And I know the architect personally, and I've known him for a number of years, and knowing that, he's done a fantastic job on this. React is a really good lightweight tool.
It seems like that takes Ascender from just being run on a schedule to actually being proactive on being some sort of monitoring and being able to push things out that way.
Polling versus event driven effectively. Which means fast response time, right? Reduces the lag. A couple of things I want to add, right? One part of this step in maintaining continuous compliance is also this phrase of being audit ready, right? It's one thing to harden your systems. It's another thing to keep them hardened. And then it's another thing to be able to prove that you have kept them hardened or kept them compliant, right? And one of the things that Ascender Pro enables you alongside the RLC Pro hardened playbooks is that at every one of these runs, we are capturing deep logging. I think Larry has a job there where you're able to generate a clean, easy to identify report. Our audit checks enable you to generate what they call OSCAP scans, HTML reports with auditors look at to see your compliance level. So that's important. And another part of retaining that compliance is, as Larry said, you know what? These guides roll. In fact, out of the blue last month, they rescinded the CMMC requirements, right? Now, one of the things that we do, so I can go to what we call upstream configuration as code. I can go get various playbooks and run them somewhere. Why do you come to us? Because not only do we pre-bake them, pre-test them, validate them to save you from doing that time, it is vendor backed and maintained. So every time that those standards re-rev, you're going to get a new version of the playbook that you can run, right? One less thing that you have to worry about. So, just think about is the time that we're taking to do this worth the cost, or is the time that we're not taking to do this worth the risk? And consider taking a look at what we offer with the combination of Ascender Pro and Pro Hard.
Yeah, that's huge. That's huge.
And Larry, by the way, you're much more than a salesman, my guy.
No. I don't get on webinars without people who are smarter than me. And you two are some of the two smartest. And it's more than just being a salesman at that point. So appreciate it.
Thank you.
Look, that's the solution at the high level. RLC Pro Hardened sets the baseline. Ascender Pro with the Hardened playbooks gets your whole fleet there and holds it against that drift. And then also leaves you that audit behind there. Brian and Larry, I want to thank you both for being here. And for all of you guys who are watching, if you want to see what this looks like in your kind of own environment, your own fleet, and what it can do for you, please reach out for us for a demo. We'd love to be able to set up a full walkthrough of what the process looks like, so you can dig into the specifics needs for your setup itself.
And if you're just starting to try to figure it out, we have a lot of those conversations. Reach out to us, right?
Absolutely. We do it every day. Also, a reminder that if you're watching this on demand, we monitor those comments. We would love to have any questions or feedback from you on what you've seen here today and how we can go going forward. So again, thank you guys for attending, and we'll see you next time.
Take care,
Thank
everyone.
you.